everybody, today we're going to be taking a look at scatter plots and lines of best fit. Sometimes this math skill comes up in a science class like chemistry when you're plotting data from an experiment. So this is a useful skill to have. You'll want to take some notes as well as have something to write with, and a calculator would be helpful as well. So let's write this definition in your notes. What is a scatter plot? Well, this is when real data does not always make a perfectly straight line. Those data points are, well, scattered all over your graph. Sometimes the data points look like this. They're very scattered. There's no real relationship between what's going on, between the x and the y variable. This is when there's no correlation, they'll say. There's no relationship between the x and the y. Sometimes the data points look like this. Positive correlation. You can see how the data points are trending upward. It looks like a positive slope. So there's a positive relationship there. Sometimes they look like this. The dots or the data points are trending downward. There's a negative correlation there, or a negative slope. I want us to take a look at an online site here real quick that has a good example of how correlations work. This is a pretty weak correlation. You can see a line of best fit that goes through them. Well, that line doesn't really need a whole lot of those dots. And as I change this, and I make it a stronger relationship, see how those data points become closer. And you can see that slope a little bit better. This is a strong positive relationship. You can see how those dots sort of trend upwards, or how they're sloping upwards. And then a strong weak or a strong negative relationship. They're trending downwards. They're pretty close to that downward sloping line. This idea is what we want to focus on today, is how do we find that line of best fit? So you probably have done some of this in a science class before, like I said, but real data is scattered like this. This is a reaction time compared to age, so how age impacts your reaction time. You can see they must have done a survey and had all these data points, and the data points don't line up perfectly. This is how it is in real life. But yet scientists may want to predict that impact that age has on somebody's reaction time. And so they would need a line of best fit to help predict, say, what an 80-year-old's reaction time might be. An 80-year-old wasn't surveyed. They aren't on our graph. But we can use this red line, if we can find this equation, to find out what their reaction time might be. So let's write this definition in your notes underneath where you wrote scatter plot there. What is a line of best fit? Well, it's a line that comes closest to the data points. It may pass through some of the points, none of the points, or all of the points, depending on your information. It's useful to show a relationship between x and y in order to predict something that's missing or predict something that's in the future. So we're going to do one example here, just one today. Take a minute and write that table of values into your notes. Okay, now let's say that you have that table of values written into your notes. We're going to make a quick scatter plot of this guy on some graph paper there that you have to the side, okay, in your notebook. What do you think we should number by in order to make this graph happen? Well, I think 0.5, since we have quite a few decimals here, decimal values. I'm going to make this be 0, 0.5, 1, 1.5, 2, 2.5, 3, and so on. Okay, and then same way up the side here. This is my 0. I'm going to draw that here in my notes. Okay, there's my x-axis. Here's my y-axis. Going up like this. X, Y. I'm going to do the same thing, numbering by 0.5. So this would be 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, and so on, making each of those 0.5. That will help us out. And then we'll make a quick scatter plot of this information. Go ahead and do that now. Plot those dots. So if I was going to plot 0.5 up 2.9, that'd be a little bit below 3. 1, 2.75, 1.5, 2.6, 2, 2.3, 2.5, 1.4, 3, 1.3, 3.5, 1.1, and 4.75. You can see that those don't make a complete straight line, and that's normal. That's real data. So this is what we have. Then we would want to actually draw a line of best fit. So somewhere in those data points, you want to draw a line that goes through maybe a couple points, has some points above the line, some points below the line. It's an estimation. It's not going to be perfect. So if you draw in your line of best fit like I have here, you would then want to write the equation of the line. So go ahead and draw that line of best fit in there. Try to hit 2 points that are on your line. Okay, so if you drew that line of best fit through my same 2 points that I have here, 1 point that's on my line is 1, 2.7. The other point that's on my line is 3, 1.3. These are the 2 points that we're going to use to write the equation of a line. Now, if you remember, writing an equation of a line means we have to find the slope and the y-intercept. So first things first, let's find the slope. Slope is y2 minus y1 over x2 minus x1. So y from the second point would be 1.3 minus y from the first point, 2.7, over x from the second point, 3, minus x from the first point, 1. So what I have here, if I go to my calculator and I calculate these values, 1.3 subtract 2.7 gives me negative 1.4. And then 3 subtract 1 is 2. And I'll simplify that. Negative 1.4 divided by 2 is negative 0.7. Oops. Negative 0.7 is my slope. Now that I know that, I'm going to turn to my trusty formula, y equals mx plus b, and start plugging in so I can solve for the b. I know slope now is negative 0.7, so I'm going to plug in negative 0.7 where the m is. And then if you remember, we'll take an x and a y from the same point and plug that in. So whichever one of those 2 points that we have written next to our graph up there that go through our line, we're going to take our favorite. My favorite right now is 1, 2.7. So I'm going to stick that in here. The 1 is the x value, so negative 0.7 times 1 plus b. And the y is the 2.7. So I'll plug that in, and now I'm going to solve. Negative 0.7 times 1 is negative 0.7 plus b. And then I'm going to add 0.7 away from the b. So b equals 3.4. So that tells me my y-intercept, according to my line of best fit, would be 3.4. So my line of best fit, to finish up this problem, to actually find that line of best fit, my line of best fit would be y equals my slope, negative 0.7, oops, meant to put the 0 in front of the decimal, 0.7x plus my b, which we just found, 3.4. This is my line of best fit, the way I have it drawn. Now, it's possible somebody else may have drawn their line of best fit through 2 different points, and they might have one that's slightly different than mine. So tomorrow when you come to class, we want to talk about truly how do we find the best line of best fit. If everybody can estimate it, then how do we know which one is the best? So we're going to use technology to help us find a more accurate line of best fit. So come to class tomorrow prepared to use a graphing calculator to help you find these lines without actually having to calculate them by hand. Thank you for listening, and I'll see you.